Uh, well, my topic today is standard inequalities because they're like not fun to do, but I guess they have to be learned because someone decided to put them on Olympiads. Like much of the inequalities in like non-algebra are like bounding, which is like done mostly by reading enough solutions. Also, and after reading the solutions, the most common reaction was bruh. So yeah. Okay, so there are a couple of okay, I have nothing to share my screen with. Okay, let's just start a whiteboard. I'm smart. So anyway, outside of algebra, the inequalities is mostly bounding, I guess. Like, but that there are exceptions to that rule. So yeah. I think I'm gonna assume that most people know what like I like Jensen or Cauchy or Holder or Muirhead or those the standard ones. I'm assuming people knows what those are, so I'm not gonna go over them, I guess. Oh, where's the whiteboard? Okay, so anyway, I'll go through a couple of interesting problems I did recently, or I guess are rather instructive. So yeah. Okay, so I made a handout with some problems on it. So I'm gonna run democracy and let people choose some examples. Some of them are well known, others are not. So yeah. Now I guess I'll run democracy and let people vote what problems they want to do. Oh wait, oops. Okay, where is Zoom? Okay. Uh, since democracy has a voter turnout of 0, I guess I'll just go in order. So the first problem is somewhat of a meme. I guess it's somewhat of a meme. It's number 2 from the like an IMO 20 years ago. The reason is because it's sort of a meme, but it's also the solution is not as trivial as you think it is. So okay, I'll start, I guess. I'm lazy, so yeah. So what we need to do is so we're given that A, B, and C are positive real numbers, and I cannot write because I have no tablet. Excuse this hideous handwriting. As you can tell, I'm using a mouse, and we want to show that we need to show that something is greater than or equal to something. I'm gonna assume that people know what cyclic sum notation is, so I'll just write it using that. So we have 3 variables, so it's gonna be a 3-term sum. So yeah, can't even write. So we need to prove that that's greater than or equal to 1. So the solution I saw on the internet was trivial by Jensen, even though it's not. So I'll explain why it's not trivial by Jensen. So once we move the a to the denominator, that becomes cyclic sum of something. It's 1 over square root of 1 plus 8 times BC over a squared. So that thing, so if we to look at the function f of x, like this is me trying to apply Jensen, it doesn't work. So if we because we have that the cyclic product of the thing I'm circling right now is equal of this term. If we cyclic multiply, it's 1, but if we cyclically sum, it's obviously not. Thus we need to add in e to the x to the thing. So now it's f of x is equal to 1 over square root of 1 plus 8 times e to the x. And then if we take the derivative of that, which isn't nice, I guess I'll just use Wolfram alpha. I don't think it was very nice. Okay, let's go use Wolfram alpha. Okay, derivative. Okay, I need to switch what I'm sharing. Okay, I'll just share this. Forgive my dishonesty. Okay, and that is taking forever for some reason. Right. Oh, never mind. And we can tell that that thing is. So this part. So we're looking for the overall reals, and we can see that it's obvious. The first derivative, it's obviously like not monotonic. So we know that the second derivative is not always the same sign. Therefore, Jensen fails slash square. Because the obvious Jensen fails, we have to instead use Holder because we don't really have any better options, I guess. Okay, so back to this. So if we apply, so we have to apply Holder instead. And how we do that would be so this this thing to the 2/3. 1 plus so then it would be this thing, the cyclic sum of the 1 over this thing. Yeah, that. So the 2/3, this should be a 3, but it looks like an omega for some reason. So that thing times a time. Oh wait, why did I rewrite it? What am I doing? So anyway, the cyclic sum of this thing, if we raise this to if we raise the circle thing to the 2/3 power, then we look at 8 times a squared plus 8bc, something like that, to the other power. Then we can use like a Holder, which is a mess. Okay, how do we do this? No, that's draw. That is complete bust. Well, Cauchy makes no sense, so this is why we're doing it this way. So then because I'm finally finished writing something using a mouse, that is greater than or equal to what is this? 2/3 times that. So this thing would then, if we multiply these terms together, then we miraculously get a plus b plus c parentheses cubed. Oh, this is a greater than or equal to sign. So this thing becomes a cubed plus b cubed plus c cubed plus 24 abc. And we know that this thing, and we know that the cubed quantity is at least. Then we know that if we divide by this thing, and then it'll go underneath this one. So how do we make it larger? Wait, can we make it larger? No, that's not possible. Okay, let's make a new whiteboard. So we can make a lemma that this thing is greater than or equal to this cubed thing. So okay. And how we would prove is just subtract these cubes, and then it would subtract these cubes, and then we can just use like mirror heads or whatever. So back to the original problem, then the cyclic sum, I'm not even gonna rewrite it again. So okay, so this thing cubed over that thing. And because because of some combination of mirror heads or whatever, this thing is greater than or equal to this thing, so we get greater than or equal to 1, which finally finishes it because I'm slow at writing. Ha ha ha. That one is sort of anticlimactic. I guess the problems back then were all kind of annoying. At least it like during grinding, like the earlier years were really annoying. So this is one of them. Okay, I'll go through a less standard example, I guess. Why am I on VTech? Okay, I don't even know where I put it. Okay, there's an okay. I'll go through I'll go in order because democracy is somehow non-existent and we have no voter turnout. So I'll go through the second example, which is a huge pile of algebraic manipulation. So I guess I'll go through it. How do we do that? Okay, I'll start another one. So so again, I don't know if anyone actually looked at the handout, but what we're trying to prove is again, so we have positive reals yet again. So what we need to show is that the cyclic sum of something. Oh, why can't I write? Why can't I write? What is this? Oh, let's try. So what we're trying to prove is cyclic sum of 1 over a plus 1 over b plus 1 is at least 3 over cube root of ABC plus 1 over that quantity and then plus 1. So the first thing I did when I saw these expressions is I noticed this quantity, and we can use a well-known theorem that the product of so the cyclic product of this thing is equal to ABC plus 1 over ABC. And then so the cyclic sum of cyclic product of A plus 1 over B and its cyclic variance is equal to ABC plus 1 over ABC plus the sum of those quantities. And it takes too long to write those again, so I'm not going to do that. Anyway, so having observed that, then we can just write XYZ or set XYZ equal to those things. Oh, Command Z doesn't work. It would be so much faster to yeah, that stuff. So once we've defined this, we can then use the relation, which gives then it would be, and then we expand to make it not so tedious. Or like not as tedious, but I guess it's still rather annoying to deal with. So obviously we're trying to cyclic sum that thing, which means that and so this thing is expandable, or I guess sort of expandable. Then it becomes something not as monstrous as if we didn't use XYZ. So here we go. Oh, why doesn't tech live exist? Then it would be xy plus yz plus zx plus 2 times x plus y plus z. Okay, let's watch me be an artist. Now that I'm finally finished with the numerator, let's just use text. So the denominator would then be okay. There, that's faster. There. Once we've obtained that, that is equal to something. Okay. Okay, I'm lazy. So now we can use the properties of the numerator. That I guess we can keep the numerator as is. We can do with the denominator as before. So the denominator becomes xy plus yz plus 2 times x plus y plus z plus 1 over. Here we also use the original ABC because it's more convenient. Plus what else? I think there was a 1. Yeah, there's still a 1. Oh, why doesn't it? So that thing in the denominator, the numerator is quite similar, so we can actually take out a 1 here. So, it's still a fraction. What is the numerator? Okay, plus 1. What is in the numerator again? The numerator is, I believe, something 2 minus ABC minus 1 over ABC, and then the denominator is still the same thing. I'll just write it in the factored form, I guess. And if we remember the ABCs in the right hand side, the right hand side is, if we also subtract out the 1, then it's quite similar. So let's do that. So now the numerator is something like we also have the same expression here. Oh wait, 2 plus I don't know. I'll just write CBRT for cube root for now. So yeah, and if we notice that this thing it divides this thing, then we can actually factor it out. So oh yeah, there's a +1 back here. Denominator is that thing. So in this form, we can actually factor out some stuff so that it's not as ugly. So first we get rid of these ones. So if we look at these two expressions again, then what the desired inequality is equivalent to some. Okay, draw a fraction line because LaTeX doesn't work inside Zoom. Then it would be 1 negative AB's. Oh. Wait, I'm having some tech issues. I need to do something. Okay, they're resolved. Okay, I'll carry on then. Painful. Okay, continue. So, oh, okay, let's erase that if possible. Okay, back to the, so the left-hand side, let me remind you again, is ABC minus 1 squared over AB. The left-hand side is that thing over then there's a +1 here is greater than or equal to something else. I did not prepare any OneNotes, so the other side is again quite similar. Oops, there should be a negative sign. Okay, yeah, it's at a minus sign. Then the denominator of this is that thing. Oh, it's almost done. So if we assume that the cube that the ABC is not equal to 1, then we can cancel stuff out. But if it is, then the inequality is trivial, so we don't really need to think about it. So we'll factor them out now. That gives us oh yeah, there's a +1 on the right hand side. Cancel +1s out, so we don't really care about those. Now we can factor out this thing. So then now we can cancel out, and also make use of the term in the denominator here. So yeah. Then what does it become? All right. Then we numerator would after canceling the things out, including the minus sign, then it would be 2/3 plus to the one. I'll start using fractional powers because it's so that it looks more consistent. Plus 1 quantity squared, and then the numerator is still the same thing. Then it's greater than or equal to. Okay, I need to. What a bust. That the left-hand side is great. Since we've gotten rid of everything in the numerator, so we have a 1 actually now. Then we notice that we almost have the almost same quantity here. I think I like forgot a factor of ABC somewhere. Oh wait, I forgot it. I forgot an ABC here. ABC to the 2/3. Okay, let's put that there. Anyway, this problem is probably more of a manipulation problem than it is about knowing inequalities. So then it should be anyway. The factor in the numerator here should be this factor, which is obtained by dividing this thing, including the minus sign, by this thing, which also includes the minus sign. So now that thing is sort of useless. So again, we removed the 1 here and then sort of cross multiply, gotten rid of this, and then we can, if we cross multiply, that gives us what? That gives us something. So after like we factor out that thing, greater than or equal to what turns out to be so like after getting rid of the 1s here and dividing by this thing, and then after expanding, we finally get this. This is proved by spamming AMGM, so we're not going to go through that. Okay, now I guess I'm basically finished droning because it's 6:30. Enjoy freedom, everyone.